Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Lokman Nur Hakim bin Ahmad Fazli. My registration number is 01DTK22F1055. So, for today, I'm gonna solve a questions in topic 2 and topic 3. The questions given is the calculate the value of VP secondary, the voltage, VRMS secondary, and I average. V average is given is equal 110 volt with load resistance RL is 1.5 k ohm for a full wave bridge rectifier. So to find V average in bridge rectifier is 2V out divided with pi. So 110 volt is V average is equal to V out divided with pi. So we need to find V out. So 100 volt times with pi and then is equal to V out. So we just carry out the 2 to the left so we can find the V out. First we times the 110 volt with pi, so we get 345.57 is equal to V2 V out. V out is equal, so we carry out the 2 to the left so we can divide. V out is equal 345.57 is equal, divide with 2 so we got V out is equal 172.78 volt. V out, sorry, my fault. And then we need to find I average. I average is equal V average divided with RL. So 110 volt divided with 1.5 k ohm. So we get 73.33 milliampere. Next step, we need to find VP secondary. As we all know, we got the output voltage before is equal 172.78 volt. And then about how to find V out is equal VP secondary minus 1.4 volt for full wave bridge rectifier. So we just substitute the equation in formula. 172.78 volt is equal VP secondary minus 1.4 volt. Bring the 1.4 volt to the left, so we will become the add operation. 172.78 volt plus 1.4 volt is equal VP secondary. VP secondary is equal 174.18 volt. And lastly is to find VRMS secondary. The formula is 0.707 times with VP secondary is equal 0.707 times with VP secondary, which is 174.18 volt. We get 123.14 for VRMS secondary. Okay, so we move to the next question, which is uh, common emitter configuration is shown in figure 1A, which is I draw it. If you can see, and if the transistor BC107 used in this circuit is silicon type, which is the value of VBE is 0.7 and beta is equal to 200. So at first we need to analysis the input loop and output loop. So the input loop is what I can see here is, wait for a second. What I can see here, the input loop is RB1 and RB2, and the output loop is RC and RE. Analysis input loop. The summation of EMF is equal of summation of V drop. Or I can conclude here is VCC is equal VRB1 plus VRB2 plus VBE. So VCC is equal IBRB1 plus IBRB2 plus VBE. So we got IB is equal VCC minus VBE is divided by RB1 plus RB2. IB is equal 20 minus with 0.7 divide with 2 kilo plus 600 kilo. So we got here 0.03 milliampere. And then we need to find, and then we got IB. And then we need to find ICQ. ICQ. IC is equal beta IB. So 200 beta times with IB, which is 0.03 milliampere. So we got 6 milliampere. We need to analyze the output loop. So the output loop is summation of EMF is equal of summation of V drop. All I can conclude here is VCC is equal VRC plus VCE plus VRE. So VCC is equal ICRC plus VCE plus IERE. So as we all know that IC is equal to IE. So VCC minus ICRC minus ICRE. So VCE is equal VCC minus IC in bracket RC plus RE. So 20 volt minus 6 milliampere in bracket 2k ohm plus 200 ohm. So we got here VCEQ is 6.8 volt. And then the last, and then not the last, sorry. And then we need to find IC saturation. To find IC saturation, VCE is equal 0. So we take the equation back from the VCE. So VCE is equal VCC minus IC in bracket RC plus RE. So VCE is 0. So is left VCC minus IC in bracket RC plus RE. So just take the IC to the left. So IC in bracket RC plus RE to the left. So IC RC plus RE is equal VCC. We just need to find IC. So VCC divide with RC plus RE. So we get 20 volt divide with 2k ohm plus 200 ohm. So we got 9.09 milliampere. To find VCE cutoff, IC is equal 0. So VCE is equal VCC minus IC in bracket RC plus RE. IC is 0. So no value there. So VCE cutoff is equal VCC. So VCE cutoff is equal 20 volt. I think that's all from me. Sorry for any inconvenience. Sorry for any of my mistake. And inshallah I will improve again. Thank you.